Hi, we're Team 4 and we're conformed by Camila, Hilda, Maggy, and Vanessa. We're going to explain topic 14. The subtopic is 14.1 called determinants. The example is matrix 2 times 2. What we have to do first is multiply the main determinant, that is 2 times minus 3. Then multiply the inverted diagonal. We have to say the main diagonal minus the inverted diagonal. And that's it.
Yay!
Oh, where is it? Just...
And now we have a matrix of order 3, and for this one we're going to use the array method. This method consists of adding the first two main columns to the right, and then multiplying the main and now the non-main diagonals. And this is the addition of the multiplication of the three main diagonals minus the addition of the multiplication of the non-main diagonals. And this is the result.
Subtopic 2. Cramer's method. The first step is to write the coefficients of the equation in a matrix. The second step is to write the two first columns to the right. And as before, you will do the addition of the multiplication of the main diagonals subtracted by the addition of the multiplication of the non-main diagonal. Here is the multiplication, the addition, and the subtraction. Finally, the determinant is equal to minus 3. If the determinant is equal to 0, there is no solution. But if you have any number, negative or positive, it would have a solution. The next step is finding x. You will write again the matrix, but instead of writing the column x, you will write the column of the result. Then, as before, you do the addition of the multiplication of the main diagonals subtracted by the addition of the multiplication of the non-main diagonals. As a result, we have x equals minus 3. For finding y is the same process. Instead of writing the column of the results on x, you will write it on y, and y equals minus 42. For finding c, you will write the column of the results on the column c. Then you would do the addition of the multiplication of the main diagonals subtracted by the addition of the multiplication of the non-main diagonals. As a result, we have z equals minus 57. And for last, you would divide the results by determinant a. Minus 3, minus 42, minus 57, divided all by minus 3. And our solutions are x equals 1, y equals 14, and z equals 19.
Now the final subtopic is cosmic. In this you have the incognitas, and in the matrix you have to put the number of the incognitas. And you have to, the point of this is to, in the main matrix, have ones, and in the diagonal you have to have zeros. And to do this, you have to make a lot of things. The first thing here is we're going to change row 1 step. Now that we have 1 in here, we have to have 0 in here. So what we are going to do is to multiply row 1 times minus 5 and add it to row 2. So now that we have 1, 0, and 0, what we have to do next is have 1 in here. So what are we going to do? We are going to divide row 2 by minus 23. The result that we got is this. What we have to do next is to have a 0 over here to conform the triangle. So we are going to multiply row 2 times 5, yes, and add it to row 3. This one. What we got is this matrix. As you may see, we already have the triangle of zeros. What we have to do next is to have a 1 over here to have the main diagonal of 1s. So we are going to divide row 3 by 223 over 23. Okay? Because we have the same in here. So when we divide it, we have this. We have our main diagonal of 1s and our triangle of zeros. What's the next step? We need to find the incognitas. This is C. So we can, if we have one C that is equal to 1, so C is equal to 1. C equal to 1. Now we have to, you have to substitute. The result is that y is equal to 1. Now we are going to get the result of x. 4 minus 6c, but c is equal to 1, so we're going to leave the 6. So we pass the 6, the minus 1, blah blah blah, and the result is x equal to 1. Thank you for watching us. Bye!